Welcome back. Today we're going to talk about a material that was discovered totally by accident. Kind of like how you were created, but at least this one happens to be a happy accident. That's right, today we're going to talk about Kevlar, the miracle material that has saved countless lives over the past few decades and has made your tires last probably a lot longer than they should. In 1964, at the company DuPont, a chemist by the name of Stephanie Kwolek was working with a team to find a new lightweight polymer for tire usage. While performing the experiment like children using a chemist set, the mixing of random chemicals resulted in what was described as a cloudy, opalescent material of low viscosity. And honestly, this would normally just be thrown out because if you looked at this, you would be just as grossed out as everyone else. However, Stephanie decided this material might be viable and persuaded the technician to spin the material into fibers. The resulting fibers were found to be even stronger than nylon, and immediately the team was like, this is pretty good, maybe we should work with this. All polymers can be broken down into their basic units, hence the name poly meaning many and mer meaning repeat unit. What is important to note here is that the repeat unit determines a lot of the properties of the polymer. Looking at Kevlar's repeat unit, we can actually note a few different things. First, we have these floating hydrogens coming off these nitrogens and these floating oxygens coming off these carbons. These play an important role in adding the immense strength that you notice in things like bulletproof vests. The reason I note these two atoms in particular is because of hydrogen bonding, where basically this hydrogen goes, I kind of like this oxygen, and this oxygen goes, I kind of like this hydrogen, and they go on a little date, and it's kind of like a Tinder match. It just kind of happens, you know? They're kind of stuck together a little bit, but not really fully committed. They're like friends with benefits. Another thing that provides a lot of strength in this polymer is this massive ring known as a benzene ring. And if you watched the previous video about diamonds, you'll know that carbons can be really strong when they're bonded to other carbons. And yeah, that's kind of it. It's just a bunch of carbons and they hold together, and that adds strength. So, yeah. The other thing that makes this polymer uniquely strong is the cross-linking of chains. Think of like a canopy of trees where all the branches kind of just interlock. You know, it looks like it's going to fall down, but it doesn't because they're actually pretty strong together. Kevlar works in a similar sense, except instead of trees, we look at polymer chains, and instead of branches, we're looking at random offshoots that just kind of touch each other. So with these properties at the really tiny level, Kevlar is kind of a wonder material. Now you might be asking, Harry, why use Kevlar when I can just wear this massive steel armor from the medieval times and I won't be hit with bullets either? That's a great question. I'm going to get there. When you wear this massive steel armor, just like when Minecraft Steve wears his diamond armor, it weighs a lot. The only difference is you are not nearly as strong as Minecraft Steve, and neither are the police. It is so much lighter and so much easier to carry around this vest of polymer than to carry tons of steel on your body so bullets won't pierce your skin. The other thing is, Kevlar actually tends to be 5 times stronger than steel when you look at it on a weight basis. So that really means if you were to put the same amount of weight of Kevlar on your body as steel, it would actually protect you better. And so really, your question was kind of stupid.
I got another question. If Kevlar is so much better than steel, why don't we just build all of the buildings around the world out of Kevlar then?
Okay, this is actually a pretty decent question. One of the largest reasons you don't see massive Kevlar buildings has to do with something that you deal with every day, and that's sunlight. Kevlar fibers tend to be very sensitive to ultraviolet radiation, just like your skin when you don't put sunblock on. The UV light can photodegrade the fibers and make them very brittle, change color, opacity, and even form cracks within the material itself. So basically, if you were to build a building out of Kevlar and then the next day it was sunny and there was a lot of UV, you might be out getting a tan and then all of a sudden the building behind you would just collapse and pancake. The other thing is, while Kevlar has a much stronger tensile strength than steel, it has a very small compressive strength. And you might be going, I wonder what he means when he says tensile and compressive. Well, let's just say tensile is like pulling a rope apart, and compressive is like crushing a can with your foot. So when you look at buildings aren't really held up by massive ropes in the sky pulling them apart from the ground, and therefore it's really mainly compressive strength that they require. So just like UV degradation, building a building with Kevlar means that it would probably fold under its own weight at some point, and just kind of pancake on top of you and maybe your brand new car, if you, own a car. So I hope that answers your questions, and if not, you can always comment them, even though I probably won't ever see them. If you learned something, which would honestly be a miracle at this point, give this video a little like. And if you didn't, well, then maybe you're in the wrong place and you really shouldn't be on YouTube anymore. Have a great one, and maybe I'll see you again.